Hi, this is Sukhmeet from the University of Florida presenting hate speech detection and its improvement using NLP and decision trees. Let's go on to the overview. So in this presentation, we'll be explaining what is hate speech and how is it different from the offensive speech, and the tools that are used in this project, the labels that have been considered, and the results. At the end, we will be considering the suggestions in the future and the conclusion. So the code has been taken from the work of Pawelski from the GitHub link given here, and there were a few changes made and a few different tweaks done to get a little better results, but almost the same. And the dataset consists of tweets labeled by the users of Crowdflower. So hate speech is a freedom of speech misused. Hate speech can be characterized as sheer misuse of freedom of speech to bully someone, and it has increased with the increased access to the internet because of the different cultures coming onto the internet and spitting out the same vulgarities which they might be using in the outside world. And it's become very important to curb hate speech because of the dispute that might arise amongst the communities, and there are articles on the internet which even claim to where authors claim that the hate speech might potentially start wars between countries. Nevertheless, it is a very big problem, and many social media companies are actively looking to curb the hate speech on their platforms. Well, the hate speech is something offensive also, but hate speech is particularly projected towards a particular community and or people of different ideologies from yourself. And an offensive speech is not particularly directed towards a community per se, but it does consist of abuses and bad words. For example, the sentence given here, "These N-word should be dumped," is a hate speech, while the B-word, "you're such a H," is offensive but not directed towards the community. So the second sentence can be directed towards an individual who might be from a community or not, but that's how the distinction has been made over here. So let's get a taste of weapons that we have used here, the tools. So there are some tweets that we have used, and first the cleaning is done, and after that some feature spaces are created from those clean tweets. So first of all, we have used the TF-IDF, or the term frequency and hyphen inverse document frequency. The term frequency, the TF-IDF weight, is a weight often used in the information retrieval and text mining. It's also used in the search engines for ranking a particular document related to a word. So a separate feature space has been made for TF-IDF, and after that we have used n-grams, basically bigrams, on the base, which mean for every 2 characters a particular relation has been recorded, and that's not only at the character level, but bigrams have also been made at the word level, so that for example, if a particular word is obfuscated using some special characters, those special characters are retained in the word, and the bigrams have been are made, so that we are able to relate those characters also with the other characters of interest, and we can form a relation of hate speech between them. And also at the word level, although we have removed these special characters so that we can avoid usage of hashtags or some special characters to obfuscate the whole word as a whole when we consider the word's context with the other words. So this is how we can consider the relation between characters as well as words, so get to get the better of both the worlds. After that, we have done some sentiment scores using external dictionaries. There are some dictionaries uh, provided with some positive words, negative words, as well as some hate-based words, and a separate feature space has been created on the basis of them. Also, Stanford parser has been used. What Stanford parser does is that it creates a hierarchical representation of it basically gives a typed dependency between words, and we can see dependency in a particular sentence itself. For example, it can be shown here. I can give a demo very quickly. So, for example, my dog also likes eating sausage. It's a sentence given to the parser, and it gives us relations, very relevant relations, like dog and likes has a good score, and likes eating has a good score. Eating sausage has a good score. So this kind of a hierarchical form is also output. Well, going further, we can see that after that we have used the classification models. We have used random forests, which are basically decision trees made using decision trees bunched together for creating a hierarchical decision making system. And after that we have used the XGBoost. This is a gradient boosting process. Gradient boosting is basically used for regression and classification problems, which produce a prediction model in the form of an ensemble of weak prediction models, typically decision trees themselves. So, and after that we have used the multi-layer perceptrons also, which are basically uh, a classification algorithm used in several different applications. And after that we have considered the simple linear regression, which we have used as a benchmark model, as it has been trained by weighting it against weighting it with the hate words. And just to mention, the labels which we have considered here are hate speech, offensive language, and neither. So we have distinguished already between hate speech and offensive language. Before we go into the results, we must mention the difficulties that we face while recognizing hate speech online or wherever, because there are some intentional obfuscations that are made. For example, the one shown here uh, with the @ and $sign, and like that. There are many other examples. There's a diversity of insults found in English language alone, and if we want to consider the other languages, there's a huge amount of data still needed for training models for the detection of hate speech. And we can see that the usage of sarcasm is quite effective too, and has to be considered separately, maybe, for training our models. For example, how lovely would it be to send them back to those chambers, which is a very dark sentence. And conversational hierarchy on social media is another point which is coming up due to the replies that we can make on social media platforms. For example, Facebook or Twitter, you can go on replying to the tweet on, and at the end you might not be able to tell the last tweet and say what is it being talked about, or what is it talking about, or how is it hate speech or not. So for a human himself, it's very difficult. So let alone the idea of training a machine so easily without having much relevant data. So a few improvements were tried here and there. Some multi-layer perceptron, the multi-layer perceptrons parameters were altered, the number of layers were changed, and the estimators and max features for random forests were tried to be altered. And AdaBoost was also tried to be included, but it gave almost similar results as the XGBoost. So the F1 scores, as you can see, are show us the baseline model to be the worst, the one with linear regression, and the random forest model has come out to be performing the best one. But going further, we will discover something more about XGBoost over here, the second model. The confusion matrix shows us that offensive language has been very strongly dealt with, and it's actually an improvement on Thomas Davidson's results, but we can see that the hate speech has suffered due to that. Although the spillover from hate speech and offensive language to the neither section is still very less. It's still considerably less. As we can see from the receiver operating characteristics curve, the XGBoost, if you consider the micro average curve over here, or the area under the curve graph, in both of them, XGBoost has performed the best, even as compared to the linear regression model, which was trained by weighting it with the hate words. So XGBoost comes out to be performing really very well when it comes to the recall, the true positive rate against the false positive rate, and XGBoost is a winner in true positivity over here. It comes very close to the linear regression model, the benchmark model, but is able to win by a few notches, although it's trained with the whole model, or whole data. So in conclusion, we can see that XGBoost can be employed for a very good recall, but the hate speech recognition still needs a lot of attention in the sector of structured data that we need to supply, and also the dictionaries that we use can be augmented, and can be augmented daily, maybe even by the moment, because there's a lot of data that is being produced by crowdsourcing and companies which can employ manual labor for the production of crowdsourced data. So in the end, we can see that the crowdsourced data itself is very much the need of the hour for hate speech detection, and that is a very good idea that can be employed here. And also it is very important to supply structured data to the algorithms, so that the machine learning algorithms are able to learn the actual hierarchy of the conversation. If the conversation is not learned well by the machine, predicting the hate speech becomes a little trickier. So that's it from my side. This was a very good project to work on, and I really enjoyed it. You can find the code in the link below, in the show more section. Hi, here is the code which I took from Topolsky. I have actually retained the name of the author also, and I tried tweaking a little bit, but the results were almost the same. So the code is almost the same as Topolsky had kept it. I have studied it and have tried to tweak a little bit of things. So at the end, I got some results: the ROC curves, the area under the curve, and I also got the confusion matrices from here. I mean, this confusion matrix is the same as this one, is that this one is the normalized one. So Thanks for watching the video.